The use of nuclear energy has the potential to accelerate, improve, and reduce the cost of interstellar travel. Nuclear rocket technology could be the future of space travel. This could significantly reduce travel time to distant locations, improve launch flexibility, and ensure astronauts' safety during spaceflight. What is this space technology, and how does it work? Join us as we investigate how nuclear power in spacecraft can revolutionize the world. While NASA pursues its Artemis program, similar to the famous Apollo program, to build a base and put people on the moon, already thinking about eventually landing humans on Mars, a rare alignment of technological, financial, and political factors is about to make space nuclear reactors a reality. In 2020, the White House set a 10-year goal for NASA to build a 10-kilowatt nuclear power plant on the lunar surface. The project is currently the top priority for the agency's space technology area. In July 2021, congressional appropriators committed $110 million to NASA to help develop a new nuclear rocket capable of taking people and cargo to other planets. And NASA didn't even ask for this money. Surprisingly, the development of a nuclear reactor for space travel does not require a major technological breakthrough. The United States practically has this technology ready because in 1965, the Air Force developed and launched a functional prototype. This technology could be used for robotic exploration of the solar system as well as expeditions to the surface of the Moon and Mars. The easiest way to understand the thrust behind rocket propulsion is to imagine the air released from an inflated balloon. As the air escapes, the balloon is propelled in the opposite direction, and the force pushing the balloon is called thrust. Most rocket engines ignite a mixture of a fuel, like liquid oxygen, to generate thrust by expelling gas from the engine nozzle.
Nuclear thermal propulsion, NTP, systems are twice as efficient and powerful as chemical rockets. The NTP system efficiently generates the heat needed to convert liquid fuel into gas and generate thrust. This system has been the subject of NASA research since the 1950s. The thrust produced by the NTP system can be double that of a normal rocket system, using the same amount of propellant, making it more powerful and twice as efficient as a chemical rocket engine. Experts predict that reducing the time it takes a rocket to reach Mars by up to 25%, or about 2 months, will reduce threats to astronauts, such as cosmic rays, microgravity, and boredom. The NTP engine will also increase the flexibility of missions to Mars. Currently, due to the weight of the fuel, the only time to go to Mars with a chemical rocket is when the orbits of Earth and Mars are perfectly aligned, which only happens every 26 months. The efficiency of the NTP system means it requires much less fuel than chemical rockets to reach Mars, and the uranium is only slightly larger than a marble, meaning fuel weight would no longer be a problem. With powerful engines, we could travel even if Earth and Mars are not in ideal locations, which is great news if you can't wait 2 years to deliver supplies or perform rescues. Nuclear propulsion would make it much easier as there would be no need to carry a lot of fuel weight. To give you an idea, the most powerful rocket ever developed by NASA, the SLS, Space Launch System, which hasn't even flown yet, was designed to lift 95 metric tons into space and costs $2 billion per launch. With this new system, its capacity would increase to over 100 metric tons. That is, if the SLS is not replaced by a more powerful and affordable rocket like the SpaceX rockets under development. Beyond enabling human exploration, establishing bases on Mars, creating multi-planetary species, and saving civilizations from extinction. If SpaceX's prediction of charging $10 per kilogram is realized, they could send larger and heavier sensors more frequently and at a reduced cost. On Mars, rovers could be sent in groups instead of individually. Fleets of satellites in low Earth orbit could become more common, and space telescopes could evolve significantly in technology, improving the fields of astronomy, planetary science, and Earth observation. SpaceX's 70-meter-tall Falcon 9 rocket revolutionized the aerospace industry,
using retro thrusters and steerable fins to create reusable rockets, something previously impossible. The company plans to launch over 50 Falcon 9 and Falcon Heavy rockets this year, averaging almost one launch per week. Two facts worth highlighting are that the Falcon 9 costs $67 million to launch, and SpaceX charges significantly less than its competitors and can be reliably and frequently reused. If all goes well, nuclear-powered spacecraft could be used to take humans to Mars. By the mid-21st century, seeing Mars and the stars could be as common as visiting the International Space Station is today.
This isn't just about faster trips or bigger payloads. It's about fundamentally reshaping our presence in space. Nuclear propulsion could usher in an era where deep space missions become routine, enabling us to unlock secrets of the cosmos currently beyond our reach, and perhaps even discover life beyond Earth within our lifetimes.
Tell me your opinion in the comments about what you think of nuclear engines and rockets, and if you weren't aware of NASA's insane mission to deflect an asteroid that could be coming towards Earth. Click on the card here in the video.